Right, a couple of public service announcements before we get started. You know there's a much better talk going on upstairs, right? Yeah? Okay, I'm assuming this is the lunchtime effect. Everybody's had a huge lunch and can't be bothered walking up the stairs. Thank you all for coming along, though. I really appreciate it. I got a new watch recently, and it's got this heart rate monitor on it. And for the last 5 minutes, it's been going up and up and up and up. If it starts bleeping, I'm probably clinically dead. As long as I'm moving, don't panic, okay? That'll be fine. Final thing, I've sent this link to the live stream to my mum and dad and my wife. So, hello, mum and dad. Hello, wife. That's just to prove that all the hours that I spent in front of a computer, instead of being outside, have actually come to something. There's actually look at this. We're at GitHub Satellite. It's amazing. It's amazing. What a venue and a keynote and all. It's been awesome so far. Right. Have we started? The timing hasn't started yet. We've started, right, good, okay. So, my name's Stuart Davidson. I'm here to talk to you about continuous deployment at Skyscanner. I'm not a vendor. I'm not someone who's here to sell you things. I'm hoping to walk you through some stories, some anecdotes of how Skyscanner got to a place of continuous deployment. It's not been easy. There's been a lot of mistakes. Basically, we've made a lot of mistakes. I would use stronger language, but we're in a public setting. And hopefully, by doing this talk, I can share the learnings that we've had, so our mistakes aren't nearly as bad. If you take something away from this, then there's value to the mistakes, and we don't feel nearly as bad. Right. So, continuous deployment. I meant to introduce myself. I'm Stuart Davidson. There was a big picture of me on previously. My handle is Spedge. At Spedge, Twitter, GitHub, LinkedIn. If you've got any, half of the reason that I come and do this is to hear where you are with your organization and what you're doing. Because we're just one small organization who's managed to do this. We're relatively small compared to some of the companies out there. I was talking to a lady that was working at SAP recently. That's a big company. So come and talk to me about where you are, what you're doing. I'm sure I can learn something from you. So I'm really keen that it continues. I'm the tribe lead of a tribe in Skyscanner called the Platform Tribe. We run all the infrastructure. So we've got enormous big Kubernetes clusters kicking around the globe. We do all the routing. We do our AWS account management, all that sort of stuff. And yeah, GitHub have asked me to come and talk about this journey. Before we get into the gubbins of it, I just wanted to very quickly discuss the difference between continuous delivery and continuous deployment. We talk about CI/CD, right? But CD is overloaded because CD could mean continuous delivery or continuous deployment. And I have sat through conference talks where they actually get the names in the wrong place, and that hurts me. So I just wanted to very quickly walk you through. Continuous delivery is where you package up your code and you get it to a place where it's tested and it's ready to go. But there's someone in your organization that decides if it goes into production or not. So that might be your QA department, it might be a release manager, someone like that. But there's a manual step between getting your code from your package management or wherever you store it into production. Whereas continuous deployment, every commit that is merged into your master branch ends up in production, right? It's all automated. So there's no one that's going, this sort of feels the right weight. You know, like these random things that we think about, these arbitrary metrics that we decide that a release is good enough or not. That's the big difference. So I'm going to talk about continuous deployment. We throw all of our merges straight into production, most of our merges into production. Right. While we're speaking, the conversations that I've had over, even just last night, the three things people want to know, and I hope I cover these, and if I don't, please come and talk to me. How did Skyscanner get to continuous deployment? What impact did it have on our business? And what lessons did we learn? I felt I should call these out just now because the rest of this talk is just stories. So yeah, hopefully I cover these three things. If I don't, please get in touch. Right, let's start. Once upon a time, cast your mind back. we're talking 2016, end of 2015, start 2016. I'm in a squad called Release Engineering. There's about 6 of us. And most of our time, we run our source control. We have an enormous Team City instance. And then we have a package management tool. And we don't really focus on the source control of the package management because most of our time is spent administrating this massive Team City instance. And I say massive, we have like 50 agents, but we're perpetually working on trying to upgrade these agents to cover all of the use cases in our business. We've got a backlog that, I was going to say, that would choke a horse. That's a Scottish phrase to say it was a very large backlog of work to do, and we were getting absolutely nowhere. And then we got this new CTO, a guy called Brian Dove, and he started to talk to us, and that was odd. Like, CXOs talking to sysadmins, it felt a bit weird, but he knew what he was talking about, right? He was clever, and he was asking good questions, and he was listening, and we started to feel like people, and it was weird, but it was a good feeling, right? We were getting attention. If only we'd seen the signs earlier, right? And I've picked a bad picture of him specifically because of this question. He came down, I remember it really clearly. He came down one day, and we were all sitting in our desks, and he came in and he said, hi folks, how's it going? And he goes, I want you to create a platform that will deploy 10,000 changes a day to our website, right? Now, I want to start off by saying this is all poetic license, okay? Yes, there was this conversation, but there was also lots of emails and plans and PowerPoint presentations, but they're not nearly as interesting for a talk like this. So this is kind of how it went, right? I want you to create a platform that will deploy 10,000 changes a day to our website. Now, we weren't sure if he was kidding or not. We weren't sure if he was making it up. So we kind of went, I think you mean 10. Now, these characters, if you're not Rick and Morty fans, these are the Meeseeks. And they're I guess a race of beings that are dedicated to helping other people. And their downfall was trying to teach people how to play golf. As a Scotsman, it was the best episode in the world. And we look a lot like that with the ginger hair and the blue skin because we have no daylight. So this is almost real life, if you can imagine. That's the Skyscanner office. We think you mean 10. He clarified, no, I actually mean 10,000. Maybe he's got his reference of data wrong. Maybe he means a year? No, he means 10,000 deployments per day, every day. So we thought we'd maybe ask him, well, how? Because he's obviously seen this great grand idea. I'm not willing to suggest where. So how do we go about this, Brian? You worked at Amazon. What do we do? He said, well, I don't really know, but that's what we pay you for. But if you need anything, support, messaging, that sort of thing, you let me know. And as he walked away, I asked for gin, but it didn't really happen. And he's yet to actually give me any sort of beverage. So I'll follow that up afterwards. But this set us into a flat spin, right? We were like, how do you even go about doing something like this? We'd heard stories, right? You hear these big internet economy companies, Facebook, Amazon, Google, these companies that have like 40,000 people doing what, well, in our company at the moment, it would be Grant, Caitlin, Fergal, and Neboja, right? And Carlos. So that's 5 individuals. Trying to do the same thing. Like, how do you get to there? How do you do that? And then we realized, actually, this set us up to investigate other things. He's cleared all the assumptions that we had before about how we had to continue to do things. And we started to look at our tooling in a different way because we absolutely knew that the tools that we were using were never going to scale to where we wanted to get to. So we've got the CTO's permission to start changing things, right? So the first thing that we investigated was our CI tooling. And I call this the Jenkins paradox because more people know about Jenkins than Team City, but it still stands. when we took a more holistic view of what our CI tooling was all about, we actually realized that our tiny little squad were setting the technical direction of the whole company, right? Because it all depended on who you knew in the squad to get the tickets along the backlog. If you wanted the latest version of Java, say, you had to get it on the build agents. And to get it on the build agents, you had to talk to us. So just depending on how much time we had, depended on what the technology choices were of the whole company. So yeah, how did we find out that we were in a strategic enabler? How did we find out we were this force multiplier for good in the company? When we realized that we were this massive strategic roadblock to getting anything done in the company. So yeah, the Jenkins paradox is this. I don't know. I've been trying to get a good way of explaining it, but basically, you have this expectation that every single bit of code that you've maybe written in the last 6 months, and that's generous. Some companies think the last 3 years, you should be able to rebuild and put into production, right? So you need this stability. You need the ability to build code at any point in the day, because it's a 24/7 thing. You might need to suddenly push out a change. So you need it stable, and you need the actual installation of code on your agents to be stable so that you can re-release that code. So that's one force. But the other force is all the new stuff that people want to try out. I want to try out like Kotlin and Lenigan and Java 11, and I want to try all these new things. But how do you build an agent that does all of that? It's impossible. You can't. You actually can't do it. Or if you do, we're hiring, right? So come and talk to us. But we couldn't make it work. So we started to look at how our CI system worked, and we discovered an open source project called Drone CI. And we've been using it for about 18 to 24 months now. It's an excellent project. And I'm so glad about the GitHub sponsorship thing that we're going to have to send a few quid his way, because it was Brad Vizitsky. He was a single contributor to this project. And he created this open source CI tool called Drone. It's not that unusual now, how Drone works. But fundamentally, it's based in containers, these ephemeral containers. And what happens is you have a container with Git in it. And it spins up and it takes the code into your, start again, apologies. You've got a Scratch container. You put a Git container on top. The Git container pulls your code into the Scratch container, and then it disappears, right? Then, and this is the critical one, you put another container on top that contains your build environment, and then you build the code that's in your Scratch container, and then you get rid of that container. That is an absolute game changer. That allows each squad to decide their own build environment. That takes all the responsibility away for agents from our squad. We've suddenly got like 70% more time back. That's crazy. I haven't finished yet, sorry. You then put a container with like Artifactory plugin or something like that, and take your code and push it to Artifactory, get rid of your Artifactory container, and then that's the work done. So you get rid of your ephemeral, your Scratch container. It's all ephemeral. Now my team only needs to worry about the infrastructure of running Drone and not the build agents and not the different software tooling. I can't describe how big a deal this was. And we had such a quick uptake because squads across the company, they all wanted this. They all wanted to control their own destiny. We work in like a squads and tribes model in Skyscanner. So each squad wants autonomy, and they can now run what they want. This led to an amazing discovery, and it was not intentional, but I say it now because I think this is maybe a really big key learning for a company that's trying to get into this area. We had inadvertently trained at least one person in every squad how to use containers, right, in Docker. Because they needed it for their build environment, and they were really empowered, like they really, really wanted to get into this. So we had trained every engineering squad in Skyscanner how to use containers. So that led us to think, right, well, we've got all this spare time, and we've got all these educated engineers now. What are we going to do with it? Here's the big plan, right? So again, this isn't like Kubernetes. This isn't massive. This is a very simple diagram of what we did in ECS, right? AWS ECS. We've got a blue-green deployment system, right? Okay, a blue-green methodology with an ELB and a Route 53 in front. 18 months ago, this was like, wow, amazing, amazing. So what we could do while there was traffic coming in was deploy, say there's traffic coming into blue, we add one container, and then the traffic's flowing between 3 containers, and then we got rid of the blue one. And that meant we were on sort of 50-50, because we would have that one and that one. So that's a split over. And then we added another green container, and then we removed the blue one. And we still dealt with production traffic. It was coming in, but we upgraded our software. We didn't need to have outages anymore. What? Like that's a huge thing. But it was a pretty simple thing to orchestrate, right? And it's N containers. And the more containers you have, the more granular you can be with your traffic. We didn't try and control the traffic at the ELB layer or anything clever like that. We just dealt with it at a container level. We still do in some places, right? This still works. This still makes money for us. But it was an absolute game changer. Then we thought, because it started to get adoption, right? This was good, but people were a little nervous about what was actually going on with their containers and the traffic that was coming in. So we took the blue container, your awesome idea, right? And it's never finished, so it's version 01. And then all the traffic coming into this container, what we did, again, not like, this isn't rocket science. This isn't, visualizing a black hole. This is really simple stuff. What we did was we put an HA proxy in front of it. So because we controlled the deployment mechanism, we could add a sidecar container of an HA proxy container and have the traffic go through it. And then what we did was we put all of the traffic, all the stats in the traffic into OpenTSDB and visualized it through Grafana, right? That blew people's minds. They were like, wow, the visibility we have on our services all of a sudden. We can start to automate we can start to do metrics checks on our containers as we rolled it out. So we could assess if we had a spike in 500s and then roll back our services if we had that spike, because the data was in OpenTSDB. But we did it just, it was like a change over a day. Somebody put just like, HA proxy container, boop-a-doo, got the config, boosh. And it happened. And then what we did was we put a log forwarder at the other end. We thought, well, this was popular enough. Let's do the other way. So we put all the logs into an elk stack. This got Brian saying things like, we can deploy an idea. And, sorry, that was a terrible American accent. I'm sorry, especially with all the Americans in the audience. He was like, yeah, we can take an idea and put it into production and have production like monitoring and logging within half an hour. Like, that is a strategic enabler. But as you can see, like the steps weren't crazy. They were just an incremental, trial and error type thing, and we ended up with this amazing system. And it's pretty simple. So our high-level architecture at kind of end of 2017 looked a bit like this. GitLab. I assumed it'd be like seeing Voldemort in a Harry Potter conference, right? Everybody's like, boo! GitLab's there. And then our continuous integration pipeline. Well, we had drone. We built our containers, and then we pushed it into Artifactory, JFrog. Then our continuous deployment pipeline, we called our system Slingshot. And Slingshot was an API that dealt with a system called Simple Workflow in AWS. Now, this is a service in AWS that few people have heard of, but it's a state engine, essentially. PayPal, I believe, don't hold me to it, but I think PayPal do all of their transactions using SWF, right? So we had an API that pushed the state of the deployment into SWF. We said, we want to start a deployment, and SWF said, you want to start a deployment. So the API said, right, I better deploy Route 53. And I said, okay, you want to deploy Route 53, right? The state was held in SWF. The reason we moved to SWF rather than it being in a bash script was in the early adoption of the early system of this, we had a deployment on a bash script that failed halfway through. And the service owner asked, well, how do I fix this? Because I'm kind of halfway through a deployment and we don't know what the state is. And we said, don't worry, just fully uninstall your service and then fully reinstall your service. And that wasn't cool because there was production traffic coming in and it was making money and things. So yeah, we, we quickly moved away from that model, and that's a key learning, okay? Don't orchestrate your deployments using a bash script. SWF, state engine, we used ECS as our scheduler. Again, it's not as glamorous as Kubernetes, but we learned an awful lot. It was there. It was ready to go. We don't need to administrate it very much. It's running in AWS. So we really thought, like, the benefits we've got, we still run a massive workload in ECS. We are moving a lot of our stuff to Kubernetes, but I feel we're getting more out of Kubernetes because we now understand the benefits that certain parts of Kubernetes brings. You don't need to go straight into Kubernetes. Have a look at what's on offer in your cloud provider. Yeah. And we started, because we could do it in containers, we actually started doing Lambdas as well. And that was, again, not a huge change to what we were doing. And yeah, you go from source code to your service, which gave the really management phrase of from source to service in 0 clicks. All right. So yeah, our CTO loved that phrase, and he used it all the time. And we got to stand in front of our investors and say things like that, and they loved it as well. Right. So this was that's end of 2017. Obviously, we've progressed since then. I did want to talk a little bit about some of the benefits of continuous deployment, because the initial reaction to the idea of every commit going into production is one of sheer terror, right? It's like, you can't, what about the QA department and the Excel spreadsheet? How do you mitigate the risk? This is a massive risk you're imposing. Every commit is going into production without a human verifying it. How can you do that? How can you take that risk on in a business? It's a good question. I would flip round the argument, right? And Richard in the audience, we talked about this last night, so it's good to have practiced this argument. Would you rather take all of the commits that you've made and your squad has made and potentially your tribe has made over the course of the week and then throw it onto production and see what happens, right? Or would you rather take each change, individual change, put it onto production and see what happens? See what the effect is. Take another one, put it onto production. Take another one, put it onto production. I would rather see what each change, what effect, what regressions it had on my platform. I would rather do them one by one. That seems less risky. That's mitigating the risk, right? So continuous deployment is potentially less risky than bundling up, months of people effort and throwing it onto production and just seeing what happens, right? The other one is, if you notice there's a problem on that big week's worth of effort, what do? You roll back a week's worth of effort. So that's put you back a whole week, right? And not only that, all of your developers are a week, they might be even 2 weeks further on, right? You've got a week of your release that was going to production. You've maybe got a week's worth of effort in your QA department, and then your developers are potentially a week's worth of development ahead. You might be 2-3 weeks behind by rejecting that release. Or what you could do is put one small change on your platform, see if it breaks anything. If it doesn't, you roll back one change and one change alone. That developer's maybe gone for coffee, right? They've come back and they've said, that didn't work, but I know why, right? Okay, the context is still in their head. The impact isn't nearly as big because it's just a very small change. And if it is, then you know exactly the change that caused the issue rather than digging through a week's worth of effort and trying to discover what went wrong, right? It's more risk mitigation. The third thing, and this is something that maybe drives me to get up in the morning, but when I was a graduate, I used to work for a company, and I won't mention the company, but I used to work for a company, and I was involved in the release engineering area. And I remember distinctly at 3 in the morning getting up to do a production release, right? So my girlfriend at the time, and my wife, was really pretty angry at me for disturbing her sleep at 3 in the morning. So already I've got that angst. I get my laptop out and I set it up on my dining table, and I'm really tired because I've had a busy day before. And I'm looking at this document, this Word document, describing all of the steps that are meant to be there. But of course, no one updates a Word document when they're updating the code, right? So there's a bit of ambiguity if this is accurate or not. And I'm taking these steps in this Word document, and I'm typing in config into text boxes that aren't doing any validation or any sort of things like that. And then I hit go, and it broke the system, right? Production failure, outage. Yes, it was at 3 in the morning. Yes, there were no customers affected, but I had no support. No one was awake to help me out. I had no idea what to do next because everybody was asleep, right? And as a graduate, are you going to go and wake up your boss because you've, stumbled in a config mistake and have to admit to him that you've heard that you've made a terrible, mistake? That's just the stress that you're putting on your people. How dare you? How dare you put that stress on individuals like that? That's not cool, right? So, mental health is a massive issue in software engineering these days. And I think that's a real aspect of what we're doing here. We can deploy during the business day. Everybody's fresh. Everyone's alert. Everyone knows what's going on. And if there is a problem, we fix it. And there are ways of mitigating your blast radius, right? You can work in different regions rather than have only one server. You can do all sorts of things to mitigate your risk, but don't put that risk on these poor individuals that are just trying to make your company work. Wow, that got a bit deep, didn't it? Sorry. Right, where was I? Right. Yeah, okay, container registries, right. Another key learning. We got into containers pretty heavily. We started using them in production when others didn't, right? You would go to these conferences and it was all like, who's using containers? Hey, who's using them in production? Boo. Right? So we started using them in production. And we discovered very quickly that one of the most important parts of your infrastructure is your container registry. And so if there's anybody from the package registry team here, I would strongly advise to understand the nuance between the two. Our code packages were stored in Artifactory, and it didn't need to be up 24/7 because if we couldn't build code, that wasn't necessarily a big problem. I mean, it was, but it wasn't. If your container registry is down and you're trying to auto-scale or you're trying to do a deployment or you have dealt with a catastrophic failure, which we did, and you're trying to spin up your cluster again, which we tried, there is a much bigger emphasis on your container registry system than your code packaging system. It's not just another code type, right? This thing needs to be up 24/7. And we had an instance where a whole cluster failed, and then it spun back up again because it's cloud native, AWS. And then it tried to grab 450 containers of different sizes and shapes all at once, which immediately made our container registry fall over because, just a heap, memory failure. And again, I'll say, if anybody was clever enough to spot, if we could have put a proxy in front of it and had a rate limiting thing, if you thought that, come and talk to me because we're hiring, right? Because that was not something we thought about. And then we had to do it on the fly. We had to put a proxy in. Oh, that was a bad 48 hours. That was sad. So yeah, this is a big warning. When you need it, when you really need it, it will fail on you. It's waiting for a chance to get you. Source control, the reason I'm here. I've just seen the next slide. I apologize for the animation. It's all gone weird. Sorry. Source control. We started to move fast. We started to make lots and lots and lots of changes on our platform, and our source control system started to creak at the edges. Now, I'm not sure how much depth I can go into here, but I will say that GitHub was tremendous. And Vitor, who's sitting at the front, and Marco, who's sitting somewhere, the two of them put together such a great story about GitHub Enterprise Server. And our adoption was slower of GitHub Enterprise because the operation model for GitHub Enterprise Server, you just spin up a single EC2 instance, right? All of the storage is local. The Elasticsearch stuff is all in there. They've got loads of scripts that copy the data over to another EC2 instance, whereas with the other vendor, we had to run our own NFS, we had to run our own Elasticsearch, we had to run a whole load of other things. Like, this was amazing, and another enabler for our ops teams and our release engineering teams to just get a bit more time in the day. So we ran this massive migration, and if I've got time, I'll talk through some of the bits and pieces, but I'm a bit nervous about that now. I've only got 5 minutes. So yeah, we migrated 8,500 repos over 10 weeks. That was a massive logistic endeavor. I think it went well. I think it went too well, because no one's thanked me yet. And I imagine, like, that's a good thing, right? If you're working as a sysadmin, you make such a fundamental change, and everybody's like, yeah, I got up the next day, and, we were in GitHub rather than GitLab, and the CI worked, and, all of the issues and, like, PRs and stuff got migrated over, and we didn't really notice. Yeah, well, good job. You're like, that's what being a systems admin is, right? You only get noticed when things go wrong. But yeah, a massive reduction in our ops overhead. One of the big things, as we were going to continuous deployment, we need to really consider our automated testing and using checks. This is an API that GitHub have that maybe you've not looked into, but it's really cool. You want to move your testing as far left as you can. So you can use your checks when you're doing an MR or something like that. You can look at your code at that point and run a smorgasbord of checks at that point. Yeah, don't wait till you're in production. That's a bad thing. Move them left. In fact, you've got bots now that'll look at your code reviews and give you comments. We've moved so far left, we're actually into the developer. So yeah, that's cool. That's a really appropriate use. So sorry for the animations. 2018, we're using GitHub, we're using ECR. So that's AWS's hosted container registry. Drone, still. Docker, still. Continuous deployment, still using Slingshot. Simple workflow, ECS, and Kubernetes now. Yeah, I don't know why I'm there. Okay, I don't work in PowerPoint, sorry. Infrastructure as code is the next big thing for us. We're like, it's not that we've solved the software deployment model. We've still got things to do, but we're iterating on it, right? We're learning things. But infrastructure as code is the next big thing for us. How do we keep up with the Kubernetes release cycle of like a major release every 10 weeks? That's fast when it comes to infrastructure. There's not enough people thinking about that as a problem and how to actually do deployments at that pace in an environment where if you get a cluster deployment wrong, that has a big blast radius. That's not just an API, that's, all of the East Coast sort of thing, right? So yeah, we're working heavily on that sort of area at the moment. And we're doing around 21,000 deploys a month. Now, you're like, wow, that's huge. No, it's not. That's the point, right? For a text box change or a spelling error, we make a change, right? So we can make 21,000 distinct changes a month on our platform. So it's just a different way of approaching it. But our risk and the amount of outages we have and things has just so substantially dropped. And Skyscanner have to deal with weird and wonderful geopolitical situations, like the president of Kazakhstan left his post, he retired, and they changed the name of the capital after him. You're like, okay, so if you're doing flight search in Skyscanner, that's a big deal, right? We have to change that. Things with like IATA codes as well. Turkey's airport changed their IATA code. One of these static bits of data that never changes, it changed, right? In fact, no, the IATA code didn't change, the airport did, right? They moved it, they changed the airport, they had to move on. Anyway, so being able to change quickly, safely, being able to react to situations that we have no control over, but we can have control over how quickly we can react to it, is a big deal for us. It's a big game-changing deal, and our company's really invested in this sort of work. Right. 1 minute. Yeah, okay, so next things that we're looking at, continuous deployment of Kubernetes I've talked about. Package management. I'm maybe one of the only people in the world to be really excited about package management, except for people at GitHub now. The announcement of this was I've been talking about the fact that package management needs to evolve over the last, 18 months to 2 years. If you look at my GitHub, I built one in Go because I felt there needed to be a cloud-native solution for this. And there's a killer feature. Because of the number of builds that we do, getting the packages onto the ephemeral build agents, we're auto-scaling, we're using spot instances. These build agents are disappearing and starting up and disappearing. So caching the artifacts in the right place at the right time is going to be critical to us going forward and scaling as a company. So I'm really interested, again, putting a bit of pressure on GitHub, but I'm here. So that's something I really want to see from package management. Working harder at reducing technical obsolescence. We build a lot of stuff, so there's now this trail of systems that never happened. We're working to improve that. 30 seconds left. Right, okay. Big, deep thoughts. Things that I have learned and observed over the last little while. Enablement. If you have a team that focuses on the enablement of others, source control, CI, things like that, enablement isn't doing things for other people. It's enabling it to do it for themselves. So don't focus on what you can do for a squad. What can a squad do for themselves, right? That's a huge distinction in how you run this software. If you're experimenting with a tool or process, try something. Don't think about a 6-month Gantt chart with like Kubernetes. Try something and you will learn and you will iterate and then you can pick something that's more relevant rather than just hypothesizing about it. I don't think we would have got to where we are today had we gone in with Kubernetes or Mesos. We just went for ECS because it was there and we tried it, we learned and we iterated. There's a lot of change in the ecosystem at the moment. Lots of tools coming out, lots of new things. Embrace this as software engineers, right? Embrace this as engineers because that's one of the reasons you got into this industry. There's lots of change. There's lots of interesting things. Try not to get too hung up on old tools and old ways of doing things. That's part of the joy of what you do. And a journey of 1,000 miles starts with a single step. We didn't think where we were going to be in 18 months. We just had a vague idea of where we wanted to head to, and we iterated. And we did one small thing after another. And I would advocate to anybody that's trying to take that path to do exactly the same. Thank you very much. I appreciate your time, everybody. If anybody's got any questions, just please reach out to me on the social media. Cheers. Thank you.